Is coming?
It's okay, sir.
It's okay now?
Yes, sir. Okay.
Just change the slide a little bit. Change the slide. No, it is not on the slideshow mode. The slideshow mode is on the right hand side bottom. হ্যাঁ, এবারে স্লাইড শো মোডে দাও, স্লাইড শো মোড, ফুল স্ক্রিন, ফুল স্ক্রিন।
It's okay.
হ্যাঁ, চেঞ্জ করো, স্লাইডটা চেঞ্জ করো।
চেঞ্জ হচ্ছে না তো দেখছি, সেটাই বলছি। চেঞ্জ হচ্ছে না,
স্লাইড শো মোডে দেওয়া হয়নি। Can someone show on the right hand bottom there is a screen type of option. On the right hand bottom there are 3 options. Tapozda?
The cursor is there, I have seen. Shankar, again if you go to the presentation mode, yeah, now you'll find, yeah, click there, yeah. Where is your cursor? Yeah. Now you try to change the slide by clipping the cursor. Yeah.
Yes.
Correct. Now it will working. Yeah.
It's okay.
Yeah. Now it is changing. Okay.
Yes, absolutely fine.
It is absolutely fine, no problem. Yeah.
Okay. The genome Aadhaar, that is individualistic, the genome that is present in any human being, we can identify those. Like that makes a significance of individual barcode for the human, this and that. The disease barcode is very much important right now. So you see there are several significant change in the single gene or multiple gene that makes the differences over there. Like a different kind of blindness and diseases, more than 10,000 diseases identified. That is a single gene, either in indels, that is the insertion or deletion, that makes the difference. Right now we can make a part on that. So this is the barcode panel that we can, gene panel. So we are basically the identify the orientation of the DNA molecules that makes the panel which help us. Okay, so why this cancer is happening? Because the multiple mutations that makes the cancer happening. And so the more than the generation of the DNA sequencing has come up in 2000, the first generation, that means the Sanger sequencing, which at the Human Genome Project have started from and continue the Sanger sequencing. Then 2006 to 10, that makes the second generation sequencing, and the third generation sequencing in 2010 to 15. Right now, the fourth generation sequences has come up. So this is more focused on the next gen sequencing that makes the difference in every corner. Every ATGC that can be measured with the next gen sequencing in a large section. So that I want to say the whole genome, exome, and targeted sequences can be designed. There are several defects. This is the human defects based on the single gene or multiple gene that can be identified very easily right now, giving the targeted sequencing or whole genome sequencing or exome sequencing, and that makes we can't go to eugenics or that part, because we want to remove this kind of deleterious genes. And NIPT is a very important technology right now. Come into the cell-free nucleic acid in the mother. See, 5 weeks of pregnancy, we can identify these deleterious genes is there or not. If there is a deleterious gene, then we can delete of that kind of genes, either different technology or just now we have discussed the CRISPRs also help us to make these kind of changes. Now that I mean to say the market value, just I am coming to the market value, the Angelina Jolie, we know an inspiration for women to undergo breast cancer testing. Now the market is, you see, the more than 18% has come up, and in North America, the 44% of market values are increasing of this kind of genetic test. Now this can be gene panel through NGS, that like a breast cancer barcode, prostate cancer barcode. This barcode can be eye barcode, organ barcode, endocrine barcode. I know the INBOL has started this kind of gene panel differentiated of different kinds of barcode with the clinicians, and that is the very good initiative that INBOL have started in this the disease barcode system with the NGS based panel, gene panel. Then another issues is very important, the storage of the DNA molecules or storage of the sequences. Now people are trying, or the different computer science or the mathematical brain that should come forward to make the storage of the DNA, that makes the DNA quick response code. That is a very important issues nowadays. Like these are the gene sequences that makes the DNA code, DNA QR code. So it may come one day that 15 pages of ATGC sequences that makes only one DNA code that help us to make the storage capacity. Scientists are working in this area, and it is very much important to DNA quick response code. And now the fourth generation sequencing platforms has come up, and that makes some kind of very nice not only genome sequences but also the image sequences and coordinate to each other. That makes the clinical and agricultural field, which might be very helpful in the next fourth generation sequences. That makes now that I told you, the Hi-Fi Genomics has come up to make the bioscan project, because we know there are lots of different kind of bioresources present in the earth, and the bioscan project has started in such a way that all the genome sequences, all the organism genome sequences should be carried out very fast. That's why the 150 kb read can be assessed at a time with that calls the Hi-Fi Genomics. The era has come, and that is started in the 2021 and onward. Hopefully, all the genome sequences in the planet can be achieved within 20 years. So now the system biology, that makes the very important technology that is coming already. Biologists, technologists, and computation, that makes the system biology to each other, that new insights, new technology, and new software can be developed, which help us for combat our new area of thoughts in the DNA technology. So that makes the genomes to life. That is in the system biology. Already we know this process which are coming in that angle, and we need to this kind of different kind of idea to give the projects over there to make fulfill ourselves to it is a innovative thoughts we have to deal with so that we can combat every corners of that part. Anyway, so now the cost is very important. The Human Genome Project have started this $1 billion, and now it is coming only the $100. Now that I want to give some kind of idea of the market of the next-gen sequencing. The market is very high. The different market survey company, they designed in such a way that it was said from this survey that in NGS and DNA sequence technology will be the highest in all areas of business. So market very high, and the analysis of this NGS part is very important to do that. So you see, right now we can do the like a $1,000, that is 1,000 genome project. Now might be it will be by Hi-Fi Genomics can be possible within the $200. We can do the whole genome sequences within the $200 with the Hi-Fi Genomics technology. And the cost is coming is very low. In 2006 or 7 onward, the cost is coming in the very low for the cost per capita. Human genome, that is in 2021, and coming 2022 and 23, it will come again only $200 because Hi-Fi Genomics has helped us to make this kind of boom. So see, the global DNA sequence market forecast, everywhere, these are the biomarker technology discovery, and this is the in 2028 it reduces, but other part in the DNA diagnostic on the genomics area is very high. Reproductive health, it is very high. Personalized medicine, it is very high. And drug discovery on the basis of genome is coming low. So the focused areas on that. And even we top 5 market by technology, what kind of technology is like this. All of the ion software sequence-based technology is coming in the highest in coming 10 years. This is the different kind of generating market and DNA forensic market. And now the COVID market, you see, COVID will not go. In the US company, they make the 2029 the cost of right now 2012, 22, 21, and the cost will be increased and plateau in that way even in 2029 in the area of genomics. So the market is, I can tell you, the market in the near future is very high, and the market like anything. And you see, this is the COVID area, and you see in 2022 it comes the double of the present situation. So the need lots of scientists, lots of technicians to make. And right now the growing of 2026 to 27 is more than 20% GR, which is the highest business market among all areas. So the what I am to say that the faculties or the students can take their career to make the online make the analysis on that part. So with these few words, and that I just give you the next gen sequencing, how in the double in 2020, the double of this, and that makes the part. So these are the multi-omics that will go. Anyway, now some of the genome to phenome is coming. Genome to phenome, that makes some kind of genomics data, phenomics data, and makes some kind of system biology experiment. This is the new generation. This is coming in 2021. USDA have started the genome to phenome in agriculture field, in particularly in agri-genomics area, particularly in the livestock area. They make so this is the one kind of genome to phenome project to combat the climate change based on the genomics and phenomics part on that. Anyway, the livestock also that makes the happening the livestock too, based on the whole genome sequences, what are the differences between, and if possible they make the CRISPR technology or genome editing and get a part on that. Anyway, even the microbiology. Now the very important issue, AI and ML in genomics is one of the biggest challenges, because so many data, so many artificial intelligence and machine learning is more component to work on the genomics area. Like some data and publication has coming up, lots of good computational biology and mathematician and genomics people get together to work on these machine learning, artificial with the phenomics, that all come into 0-1, what the genomic signatures is there that make the diversity and all the part on that. So machine learning, a deep learning model for prediction of next generation sequencing depth from the DNA sequences. So this is a one part of the deep learning process, the phylogenetic relationship of the butterfly. So with this few word, I thanks to organizer to give a chance over me. Thank you all. Thank you. Stop presenting. Oh. Sorry for disruption. I'm using the Surface Pro, which I have not used basically. That's okay.
No, it's okay. I shall take 2 minutes only.
Okay. Now we come in the summation of the part, and just make a vote of thanks from our mentor, Dr. Shivori Datta, who is always with us in the involved team and giving every time our suggestions, speak up, everything. I request Dr. Shivori Datta to make the summation and vote of thanks, please.
All the lectures were very good, thought-provoking and captivating, to say the least. I can say it is actually an alpha to omega lectures, starting from the very beginning to till the end, packing almost 70 years discovery with 2 hours of time is very tough job. But all the 3 speakers, Professor Taposh Sengupta, Professor Kaushik Biswas and Professor Shankar Ghosh, they have done their job very efficiently, very nicely and very lucidly. I know all of them. Actually, Taposh and Shankar is known to me for over 40 years. I know Kaushik as well. As an alumnus of Bose Institute, I have seen him a few times at the Bose Institute as well. All have spoken very, very lucidly. Nothing to sum up because they were all self-explanatory. One line I remember, what we have learned in our college days about the value of pi. I like to mention that line, how I feel alcoholic after 3 heavy lectures on omics. Actually, all those lectures were very much thought-provoking, so much so that it will lead at least me a few weeks' time to think all over it. Like Kaushik, during Tapo's lecture, Professor Taposh Sengupta, I was to some extent nostalgic as the same lecture, almost the same lecture, I have heard in 1977 at the Science Institute in Biophysics Division from Professor Sudhamoy Ghosh, which actually inspired me to come from pure chemistry to biochemistry to join Bose Institute as a PhD scholar. And there I have met during my final days Tapas Sengupta and Shankar Ghosh. So they are now very good friends of mine. Uh, Kaushik Biswas, a little bit junior to them, to me as well. But he's a nice guy. He explained the very difficult topic so lucidly. So CRISPR-Cas9 probably gave rise to designer baby. The very nice thing. But before that, designer baby, whether it will be good or bad, everybody will want one Einstein at their home. That will be a dangerous thing. So that is one ethical question on that. We should remember. Before that, what Professor Ghosh mentioned, actually, an involved healthcare is doing, taking care of health through genome editing, through barcoding, will be rather more important than creating a designer baby. It is my personal view, of course. If you have enough money, definitely you can go for a designer baby, but you can help crores of people to lead a healthy life with the help of this genetic engineering, gene therapy, so to say. I must mention the name of Tapas Sengupta, who has almost reached the level of popular science lecture, and everybody will understand his lecture. He was so lucid, he started from the very beginning, and the discovery of DNA stated so finely that even a student of class 8 will understand it. So he deserves special thanks for that. Professor Kaushik Biswas has done a marvelous job. He packed nearly 70 years discovery within 1 hour time, less than 1 year, 50 minutes time. Also, heartfelt thanks to Professor Shankar Ghosh. Due to time constraint, he couldn't explain everything, but I could get that there are lots of things in barcoding, and that may lead to healthcare system rise to a very definite height, a special height, and possibly Invol is doing that. At the first place, Invol is trying to mobilize students at the PG level, at the doctoral level, to train them, to train their mind, to train with hands-on trainings, etc., so that they come up with high-level genetic engineering techniques to help people at large, to help society at large. So that is a noble attempt, and I think it is the kind of institute first of its kind, at least in India. I wish grand success for it. Now I must thank all the speakers, Professor Tapas Sengupta, Professor Kaushik Biswas, Professor Shankar Ghosh, especially the audience. The audience made it a grand success, and of course, who did their work behind the scene, the Invol team, without whose support this program could not have been materialized. So thanks to them as well. I would like to mention just one thing and then complete. Though Tapas mentioned the name of Rosalind Franklin, in my view, so of course this was my view, she actually led hard observation, hard discovery, led to the Watson Crick model. The model goes by the name of Watson and Crick, but the X-ray photograph, which is known as the most beautiful X-ray photograph, not only of this century, but discovered till date or done till date, the most beautiful X-ray photograph of Rosalind Franklin, that led to the idea of DNA double helix. Actually, was first shown in a seminar lecture by his colleague Morris uh, without her consent. That was not a good thing. And Rosalind remained to some extent neglected. Though Morris, Watson, Crick, all were awarded Nobel Prize, she deserved it also. Unfortunately, she died in 1958, and the award goes to these three in 1962. Till date, posthumous award is not there, so she didn't get it, or she was somehow neglected. That is a different thing, but she should be mentioned with due honor and due importance everywhere, that it was Rosalind's discovery, Rosalind's observation. Commonly, or she was fond of having the name Rose, ROS. Actually, the seed that led to Watson Crick model. Okay, that is my personal view, of course. I feel very much sorry for her, who actually laid down her life for this discovery. She was exposed to high X-ray radiation that led to her ovarian cancer. She died at that point of time. That one's treatment was not there. She died at the age of 38, but she laid the foundation for the discovery of DNA double helix. Okay, it's a very nice lectures. Again, I thank you, Taposh Sengupta, Professor Taposh Sengupta, Professor Kaushik Biswas, Professor Shankar Kumar Ghosh, the INVOL team, and the audience at large. Continue doing this thing at regular intervals. Continue to educate us and educate the society, and continue your good job to help the society to have to live with good health, because your organization is known as INVOL Healthcare. So training the student with one hand and helping the people to lead a good life in good health with another hand is the main motto of INVOL. I hope that INVOL will continue to do that. I will invite all the audience and everybody to visit INVOL at their convenience. We will welcome them. We will show them how we are doing. And thank you very much. Have a very nice week ahead. And thank you all. This is all for today. Okay.
Okay, thank you all. I'll see you again someday or as involved. Okay, thank you. Thank you, Tapushla.
Yeah, thank you also. Thank you also.
Thank you.
Very
Thank
nice.
you.
Very nice.
Good night, everybody.
Yeah, thank you.
Good night.
Good night.
Good night. Bye. We'll see you.
Okay.
Okay.
Thank you,
Okay.
Shivarida.
Okay.
Good night.
It is a nice program.
Thank you.
Nice arrangement. Yeah. I also learned so many things from Shankar's talk and Kaushik's talk. Yeah.
Kaushik
Okay.
is excellent. Right. Okay. Bye.
Okay. ठीक है.